Hello viewers, this is Dr. D. Rajalakshmi, Associate Professor in CSE Department of RMD Engineering College. In today's session, we are going to see about primitives for distributed communication. We can classify primitives for distributed communication into two broad categories. One is blocking versus non-blocking primitives and another one is synchronous versus asynchronous primitives. Let's see about the communication primitives. Message send and message receive communication primitives are denoted send and receive respectively. Send primitives has two parameters. The first parameter is the destination. Second parameter is the buffer in the user space containing the data to be sent. A receive primitive has two parameters. The first parameter is the source from which the data is to received. The second parameter is the user buffer into which the data is to be received. There are two ways of sending data when the send primitive is invoked. One is the buffered option, another one is the unbuffered option. In the buffered option, the data is copied from the user buffer to the kernel buffer. Then the data later gets copied from the kernel buffer into the network. In the case of unbuffered option, the data gets copied directly from the user buffer onto the network. For receive primitives, the buffered option is usually required because the data may already have arrived when the primitive is invoked and needs storage place in the kernel. Now let's see about synchronous primitives. Send and receive primitives are handshaking with each other. The processing for the send primitive completes only after the invoking processor learns that the receive primitive has also been invoked and the receive operation has been completed. The processing for the receive primitive completes when the data to be received is copied into the receiver's user buffer. What is asynchronous primitives? A send primitive is said to be asynchronous if control returns back to the invoking process after the data item to be sent has been copied out of the user specified buffer. It does not make sense to define asynchronous receive primitives. Now let's see about blocking primitives and non-blocking primitives. What is blocking primitives? A primitive is blocking if control returns to the invoking process after the processing for the primitive synchronous or asynchronous mode completes. Then what is non-blocking primitives? If control returns back to the invoking process immediately after invocation, even though the operation has not completed. For a non-blocking send, control returns to the process even before the data is copies out of the user buffer. For a non-blocking receive, control returns to the process even before the data may have arrived from the sender. Now let's see about blocking synchronous send and blocking receive operations. In the case of blocking synchronous send, according to this diagram, process I, this is the sender process I invokes send operation and the data gets copied from the user buffer to the sender buffer. The data copies from the user buffer to the kernel buffer and is then sent over the network. And now the data is copied to the receiver's system buffer. A receive call has been issued. Here the receive call has been issued. An acknowledgement back to the sender causes control to return to the process that invoke the send operation and completes the send operation. In this way only the blocking synchronous send operation works. Now let's see blocking receive operation. The receive operation starts here. The receive call blocks until the data expected arrives and is written in the specified user buffer. Here only the data is written in the specified user buffer. So now the control backs here, and now from here to here the receive operation is blocked. So in this way only the blocking receive operation works. Now let's see about non-blocking operations. In the case of non-blocking synchronous send, control returns back to the invoking process as soon as the copy of data from the user buffer to the kernel buffer is initiated. Here only the send operation started. Now here itself the control return backs to the invoking process as soon as the copy of data from the user buffer to the kernel buffer is initiated. Now what is non-blocking receive? This is the non-blocking receive. In the case of non-blocking receive, the control returns to the process even before the data may have arrived from the sender. Here only the data arrives, but the control return backs to the process even before the data may have arrived from the sender. Now let's see about blocking asynchronous send and non-blocking asynchronous send. What is blocking asynchronous send? Here the user process that invokes the send is blocked until the data is copied from the user's buffer to the kernel buffer. For the unbuffered option, the user process that invokes the send is blocked until the data is copied from the user's buffer to the network. Non-blocking asynchronous send. The user process that invokes the send is blocked until the transfer of the data from the user's buffer to the kernel buffer is initiated. Thank you.